Let's take a look at how to identify the features of a quadratic function when it's in vertex form. And really what we're doing is identifying the features of a parabola when we have its function expressed in vertex form. Remember that quadratic functions are often expressed in either standard form or vertex form. So standard form, f of x is equal to ax squared plus bx plus c. Compare that to vertex form. F of x is equal to a times the quantity x minus h squared plus k. From the vertex form, we can easily identify the vertex, the axis of symmetry, and the opening direction. And let's see how we do that. So let's take a closer look at the vertex form. From our work in transformations and translations, we can see that in vertex form, it's going to be pretty easy to identify these translations. And recall that our translations are generally in reference to the parent function. So here's our vertex form where that big purple arrow is pointing. And the parent for this particular one is f of x is equal to x squared. Remember, that's the basic quadratic. So looking at our vertex form and thinking about what you learned about how to decipher translations, you can see that the h gives us our horizontal translation. So that's going to tell us how many units we're moving from the left or right. And k gives us our vertical translation. So are we going up or down and how far? And again, that's in relation to our basic quadratic parent, which is f of x is equal to x squared. And if you recall, the vertex of that parent is at 0, 0. So we're translating that vertex h units in the horizontal direction and k units in the vertical direction. Now that coefficient a actually tells us what our opening direction is. If a is positive, our parabola is going to open upwards, and if a is negative, our parabola is going to open downwards. Let's try it on an example. G of x. So let's take a look and see if we can figure out the vertex, the axis of symmetry, and which way the parabola opens. So for the vertex, we have to find h, and h you can see is -1, and we have to find k, and that is -3. So hk tell us how far away from 0, 0 we are. Well, we're 1 to the left and 3 down from 0, 0. So our new vertex is at -1, -3, which means that our axis of symmetry is x is equal to -1. Remember, that's the vertical line that splits our parabola in half vertically. And last, our parabola opens upwards because our a coefficient, 3, is a positive number, so we know that means that we're going to open upwards. Okay, here's 3 examples. Good idea if you want to pause now, see if you can work them, pick out the features, and then come back and I'll put the answers up for you. First example, g of x. Our vertex is at 5, 2, so it's been translated to the right 5 units and up 2 units. That means the axis of symmetry is x is equal to 5, and our leading coefficient, our a, is negative, so that means our parabola is going to be opening downwards. Second example, h of x. Our vertex is going to shift to the left 4, so -4, and it's going to go up 6, so -4, 6. Our axis of symmetry will be x is equal to -4, and our parabola opens upwards because our a coefficient is positive. Last one, k of x. Our vertex is going to shift to the left by 8 units, -8, and it's going to shift down by 4 units, so our new vertex is at -8, -4, which gives us an axis of symmetry of x is equal to -8, and because our a coefficient is negative, it's a -2, our parabola is going to open downwards. Recapping, we know that quadratic functions can be expressed in standard form or vertex form. And standard form and vertex form, compare the two. We took a look at the difference. When you have your function in vertex form, it's pretty easy to pick out the vertex, the axis of symmetry, and the opening direction.